Okay, today our topic is design of structural element, and I am the person for the day. My name is Joe Joshua. I am BIM application engineer, grade 1 from structural department. Okay, and first before moving on to topic, I want to tell you about our organization. Hello. Hmm, okay. All of you, please mute your mics. Okay. Okay. So I want to speak about our first. I want to tell you about our organization, BIMLABS Global, which is situated in the southern states of Kerala. We are an Autodesk learning partner and member of Indian Green Building Council, and our business areas are BIM training for students and for corporates, BIM implementation support for corporates and organization, BIM project outsourcing, BIM placement service. Okay, these are our main business areas. Okay, for more details, you can contact us through Facebook, Instagram, web, and LinkedIn. Okay, our email ID also. Okay, these are our certifications. Okay, we have certification winners for IGBC, Indian Green Building Council, and we are a proud trainer of Bentley Institute and Bexel Management, and we are an authorized reseller of BridgeCAD. Okay, and we are an Indian Building Information Modeling Association. Okay, certificate member, and we are Autodesk authorized academic partner, AB site authorization, and Autodesk authorized training center. ATC site authorization. Okay. Next, our office. Okay. Our main corporate office is situated in Calcutta, which is in Tirunelveli, and we have a branch office also. We have 3 branch office, and first branch office is situated in Statue, which is also in Tirunelveli, and the next our branch office, which is in KK Road, and which is situated in Cochin, and the branch office and another branch office which is in Calicut, and we have a project management section, which is located in Dubai, and BIM Studio, which is now currently in Techno City, Tirunelveli in phase 4. Okay, and this is our structure. Okay, our BIM Labs global structure. Okay, we have a finishing school, BIM Studio, and Bridge. Okay, in the finishing school, we upskill our students to CAD, BIM, CAM, and CA courses. Okay, with the project internship and soft skill training like that. We upskill them. Okay, in BIM Studios, we give them a BIM design and documentation project, a CAD, and BIM implementation. Okay, when after upskilling, provide them industrial training and all. Okay, we provide them how BIM implementation is taking place. Like that, we give them training and all. Okay, next is the bridge. This is our placement unit. Okay, this is our placement unit. After finishing school and BIM studio, they are trained for giving to the industrial area. Okay, so for that we give them the bridge placement. Okay, we give them bridge placement, CAD BIM services tied with KE firm in South India, and we have placed over 60 students in the last 2 years. Okay, and BIMLABS Engine Private Limited is also an Autodesk learning partner, as I mentioned earlier, an Autodesk learning partner, the IGBC registered institute, Indian Green Building Institute, registered institute. Okay, and next we have the capacity of building partners varies across AEC. Okay, architecture, engineering, construction. Okay, in firms in South India. Okay, and we are authorized training center in Autodesk, Bentley, and authorized academic partner of Autodesk, and we are also the member of Indian BIM Association, IGBC. IGBC, and Indian Green Building Council. Okay, I hope you got a clear view of our organization. Okay, okay. Next, next we are going for the topic of the day. Okay, design of structural elements. So this is what we're going to discuss throughout in this session. Okay, design of structural elements. Okay, next, this is agenda. This is what we are going to discuss for the course throughout for this 1 hour. Okay, so what is a structural element? So there are so many elements which I have listed out there, and there are so many other more elements. Okay, the basic definition is that what load bearing elements of the building. Okay, basically structural elements are the load bearing, and which helps us to withstand the load which is given under the buildings. Okay, mainly beams, columns, slab, flat slab, void slab, footing, shear wall, like that. There are so many buildings. Okay, there are so many structures. Okay, sorry, so many structures. Okay, so these are the sometimes you may say load. Okay, load, there are several types of load, right? Dead load, live load, and then another eccentric load. Okay, building load. There are so many types of load. So for withstanding that types of load, that different types of load, we use structural element for withstanding that load. Okay, first and main thing you have to understand is of structural elements is that structural elements are basically load bearing elements. Okay, their main purpose is to withstand the load. If they can't withstand the load, the building may go into failure. Okay, that's a major thing you have to understand. Okay, if they're going to measure what is the use of building. Okay, that's no use. So our main priority is to maintain a proper design of and the load bearing and calculation of that. Okay, so if anyone asks you what is a structural and what is the purpose of it, so the first point you have to bring out is that it's a its main purpose is load bearing. Okay, of the whole entire structure. Okay, if anyone asks you about what are the elements, you can mention that beams, columns, slabs. There are different sizes of slab. That's I mentioned flat slabs, and there are voided slab like that. Footings. Okay, that footings. There are different classification. Isolated footing. Mat foundation like that there are so many types of rectangular footing, trapezoidal footing, like that. Okay, shear wall is another type of structural element which is used to resist the vertical loads. Okay, when seismic wind pressure like that, which is used to resist that types of load. Okay, next when I begin the topic, when I started design of structural elements. Okay, that's what the title means. Okay, so everybody, I think most of you in this session, they will think design means okay, design of concrete. No, that doesn't mean design of concrete. Okay, so it means design of timber design, composite structure, structural steel, RCC. That's what the concrete structure, reinforced concrete structures. Okay, the concrete section. Okay, there are so many types of design. So if anyone asks you about a design, don't tell it's only about concrete. Okay, don't tell it's concrete only. Okay, it's more than that. We have so many items to design: timber design, composite structure design, structural steel design, RCC. Timber means wood. There are so many different types of wood design and also not only the ordinary teak wood like that. There are so many structural woods available in the market. But in future you can know when we go into construction. But okay, timber design like that. We have different codes for it also timber design. Okay, and in composite construction, when we when we see in composite construction, it's a combination of what structural steel and concrete. Okay, not reinforcement. Okay, reinforcement bars. It's a I section like that. I section and concrete, and then I section. So like a sandwich construction. Okay, so like that. Composite structure design is made, and a structural steel for an I section, L section. There are so many type of structural steels available in the market. Okay, so for that, so we have to give as per the client's requirement, we have to design the L section. Okay, and requirement around how load can withstand and not. Okay, so that's what we structural steel design. RCC, as I mentioned earlier in this. In this design of concrete structure, we all know design of column, design of beam, design like that. RCC where steel reinforcement, everything is applied in it. Okay. Okay, I hope you understand this much. And in concrete design, we have some ingredients and all. Okay, so in term, we call first we have the binder, which is the cement. Okay, which binds this fine and coarse aggregate together. Okay, we bind it. Okay, the second one is fine aggregate, okay, the fine particles, and the third one is the coarse aggregate. Okay, the fourth one, when this are combined together, we get the concrete structure. And when we add when we add the reinforcement steel bars, okay, we get the RCC structure. Okay, the binder is the one which binds together, and activator which activates that process. Okay, when binder, fine aggregate are mixed, then water is added into it, right? When the water is added, it gets activated. Okay, and so we say, change in terms, we say like this: we have ingredients, we have a binder, we have a fine aggregate, we have a coarse aggregate, and we have an activator. Okay, so these four are things, ingredients that we need in during the concrete design. Okay, so codes. Okay, as mentioned, codes. Okay, as we design, for each country there are specific standards of design of any elements. Okay, so today in this session I am only talking about Indian standards. So there are certain other standards: American standards, European standard, British standard, Canadian standard. Why are they providing these standards? Because for each topography, okay, for each topography and all, so why are we providing this input standards? Okay, so for each topography, okay, for each topography, if I consider India, okay, for India, this there are different locations. Okay, so same topographic identity is not applicable in America and all. Okay, right? So there are different climate and that area, the land, the soil, so many factors are there, right? The rivers and all, like that, soil set. So many properties. Based on that, they discover the whole part of the nation, right? So based on that, they derive these standards and all. Okay, there are Indian standards, American standard, European standard, British standard, Canadian standard. Okay, so based on that, so we should follow as an engineer, as we are an engineer, so we should follow these standards, and we have to proceed further. Okay, so this is our main weapon as an engineer, as we are design engineer, the structural design engineer. Our codes are our main what main weapon, or our like that dictionary, okay, or encyclopedia, like that. Okay, so we can say like that. So next, as I mentioned in today's topic, I am only mentioning about the Indian standards only, right? So currently I am only mentioning about the Indian standards. Okay, so IS 875 part 1 to part 1 to 5, we have live load, dead load, wind load, and snow load, and we have the load combination like that. And ISN, which is related to seismic, and IS 800 2007, which is the steel design, IS 456 2000, which is only dependent on the concrete design, IS 883 2013, which is the timber design. Like that, the European codes, they have also some codes where, for example, I say European code EN 993, okay, which is used for steel, and EN 990, which is used for basic structural steel, like that. Okay, so there are ASI codes also, ACI 318, which is used for concrete loading, like that. EN 2004, which is a composite structure. Like that, there are so many codes and all. Okay, if we go for each country, like the Indian standards, they all have their own specification and standards. Okay, we have to if we go to other country, we have to follow that standards, we have to follow that standards, and we have to make the design. Okay, following each and every standard only we can make the design. Okay, so each and every important the codes are basically based on the topography of that area. Okay, so each and every code is important for us. Okay, so next is the design philosophy. Okay, the design philosophy. I think most of you heard of the design philosophies. So these three are our main ISO based philosophy, design philosophy. Okay. Uh, so the major three, as I mentioned here, the working stress method, the load factor, or ultimate load method, and limit state method. These three are the major philosophies. Okay. So based on these three methods, our IS code designs are made. Okay. So there, for before that, we have lot of philosophies and all. Okay. So now currently we are coming to an end, and these three are the major, but the major ones which is which has been used until date. Okay. And next, when coming to the working stress method, this is one of the oldest method, and basically it is based on the elastic theory, which assumes that both steel and concrete are elastic and obey Hooke's law. I hope all of you know what Hooke's law is. Hooke's law is nothing but stress directly proportional to strain up to the point of collapse. Okay, that's what Hooke's law is. Okay, in this method, the ultimate strength of the concrete and the yield strength or 0.2% improved strength is divided by the factor of safety to obtain the permissible stress. Okay, so that's the main point we have to consider. The ultimate strength of the concrete, right? The ultimate strength of the concrete and the yield strength or the proof or the 0.2% of proof stress of the steel are divided by the factor of safety. Okay, the factor of safety we made up heard it's 1.53 to like that. We have so much we have direct to obtain a permissible stress. Okay, okay. As per the IS, as per our IS code, okay, as per the IS code 456, a factor of safety of 3 is to be used. Okay, a 3 is to be used for bending and in compressive stress in concrete. Okay, and 1.78 for yield or proof strength of the steel. Okay, okay. I hope you understand this much. Okay, I will say slowly once more. Okay, this method, oldest method, and basically based on the elastic theory. And we assume that both steel and concrete are elastic in nature, and they both obey Hooke's law. Okay, they both obey Hooke's law, which means that stress is directly proportional up to strain. And the next point is that the ultimate strength of a concrete and the yield strength of concrete, or and the yield strength, or the 0.2% of proof stress of steel are divided by the factor of safety to obtain a permissible stress, which can be obtained. Okay, which can be obtained. And the third point is we say that as per IS 456, the concrete code, a, a factor of safety of 3 can be used for bending in compressive stress in concrete, and 1.78 for yield or proof strength of steel. Okay. Next, this working stress method, as I mentioned, is one of the oldest method and is also currently used. Okay. This working stress method also used currently. Okay, is mainly used for design of water dams, water tank, and the main reason is that it does not account for the variation of loads, and design is mostly conservative. Okay, okay, since water tank and dams are more vulnerable, so limit state method. When we go further, you will learn more about. Okay, so limit state method we go through what economicity like that economical. We should use less concrete, less steel like that. But in working stress method, when we go through it, and when it's also detailed in IS 456 2000. When we go through it, which mainly the sections are very thick, right? Not very much like the limb state. Okay, it's very thick. They don't give like they do not give. They don't say that use only this much. We have to be more green like that. So these dams and water structures are very important, right? They should be built for a lifetime, right? So so for that, limit state method is not good, or what I say, not useful. Okay. So for that reason, we use working stress method. So if anyone asks you, is working stress method still used? And you can say that yes, it's still used. It's still used for water tank and dams. Okay. It's still used for water tanks and the design of tanks. Design of tanks. Okay. Dams. Okay. Okay. I hope you understand. And next is the ultimate load method, or we can say another name, load factor method. Okay. In this method, the ultimate or the load or the collapse load is used as the design load. Okay. The ultimate loads are obtained by increasing the working or service load. Okay. So so typically we have some factors and all. Okay. These factors may be multiplied which are multiplied and is known as load factors. Okay, these load factors use the exact margin of safety in terms of load. Okay, this method uses a real stress strain curve. Okay, the real stress strain curve of concrete and steel and takes it into the plastic behavior of the material. Okay, so I shall repeat it once more. Then basically in this method, ultimate or collapse load is used as a design load. Okay, the ultimate loads are obtained by increasing the working or service loads suitably by some factors. Okay, these factors which are multiplied are called load factors. Okay, these load factors which gives the exact margin of the safety in terms of load. Okay, and the last point, this method uses the real stress strain curve of concrete and steel and takes into the plastic behavior of the material. Okay, so in this down bottom side, you can see the load factor equal to the collapse load by working load. Okay, I hope you understand this much. So coming to the limit state method, as most of you are most familiar with it. Okay, it is the combination of both working stress and ultimate load method of design. Okay, so okay, as I mentioned, the limit state mainly focus on safety at ultimate load and serviceability at working loads. Okay, they mainly focus on safety of ultimate and serviceability, part of works, part of services it can do at working loads. Okay, okay, the acceptable. So the limit state and basic definition that I indicated here is that the acceptable limits of safety and serviceability requirement before failure occurs are called as the limit state. Okay, please note the point. The acceptable limits of safety and serviceability requirement for failure occurs are called the limit state. Okay, so our limit state method is basically from the British code. Okay, British Indian standards. Okay, so there are two types of limit state we go into: limit state of collapse and limit state of serviceability. Okay, limit state of collapse and limit state of serviceability. Okay, these are the two types of limit state we are going to detail right now. Okay, limit state of collapse. Okay, limit state of collapse is reached when the structure as a whole or part of the structure is collapsed. Okay, when the limit state of collapse is reached when the structure as a whole, the structure as a whole body of the structure collapse. Okay, so limit state of collapse, several types of limit state of collapse are there. Limit state of collapse in flexure, limit state of collapse in shear, limit state of collapse in torsion, limit state of collapse in axial load. Okay, these are the four types of limit state of collapse we have. Okay, so I will go through the first two. One, the limit state in flexion, limit state of collapse in flexion. Okay, the resistance to bending at every section shall not be less than the appropriate values at that section produced by the most unfavorable combination of load. Okay, of the structure of the loads on structures using appropriate partial safety factor. It is called limit state of collapse in bending also. Okay, I will repeat it once more. The resistance to bending at every section shall not be less than the appropriate values at that section produced by the probable most unfavorable combination of loads on structures using appropriate partial safety. It is also called limit state of collapse in bending. Okay, so if you want to get more details in limit state of collapse in fracture, you can refer page 69 of IS 456 2000, which shows the details of limit state of collapse in fracture in clause 838. Okay, there are different assumptions related to that. You can refer the Indian standard codes and all, and you can check. Check it. Okay. So next one is limit state collapse in shear. Okay, shear is loaded in beam and caused by variation of bending moment along the span. Okay, it is caused along the span. Okay, The variation in bending stress at two cross section at two cross section in the same fiber gives rise to the horizontal shear. Okay. So I repeat that sentence. I hope you get it. The variation in bending stress at two cross section. Okay. The two cross section in the same fiber. Okay. I mean same section gives rise to the horizontal shear. Okay. A combination of shear stress and bending stress produces a principal tension and at the support, and is called diagonal tension. Okay. It's called diagonal tension, and the diagonal tension occurs at an angle of 45 degrees. Okay. Okay. A combination of shear stress and bending stress. Okay. Shear and bending are act together. Okay. They produce a principal tension and which is at the support. It is acting at the support and is called the diagonal tension, and which acts at an angle of 45 degrees. Okay. So the next point is, as concrete is weak in tension, these uh, tensile stresses produce cracks. Okay. In the member, and hence member should be checked for safety against shear failure. Okay. So it's the shear failure check is one of the important check we have to do for every concrete design. Okay. So if the shear stress is large is large. If when the shear stress is large, okay, the steel in the form of vertical strength should be provided. Okay. So for resisting shear and we provide stirrups. Okay. So note that. So for resisting shear we provide stirrups. Okay. Okay, we provide a stirrup and should be provided to take the tensile stress. Okay. So next is limit state of serviceability. Okay, what are services which it can give? So limit state of service is related to the satisfied performance of the structure. That well to know. So how much it gives us, how much satisfaction the structure gives us. That's what we are going to learn. Okay. Okay. As before we have mentioned. Now also we have limit state in deflection, limit state in cracking, limit state in vibration, limit state of corrosion. These are the major limit state of serviceability that we have. Okay, these are the four types. Okay, once more I will say limit state of collapse in deflection, limit state collapse in cracking, limit state of collapse in vibration, limit state of collapse in corrosion. Okay, so deflection of the structure, but which does not adversely affect the appearance of the structure. Okay, so it does not appearance of the structure. So how to control deflection and all, you can refer the page 39 of IS code 456/2000 and shows the details of how the deflection is controlled, and you can check the clause 23.6, the control of deflection. Okay. Next is limit state of collapse in cracking. Cracking of the structure should not appear the appearance of the structure, right? The acceptable limits of cracking would vary based on the type of structure and environment. Okay, based on the type of structure and environment. Okay, that's what say. So I will say it once more. Okay, I will say it once more. The cracking of the structure should not adversely affect the appearance of the structure. Okay, it doesn't does not adversely affect the appearance of structure, but the acceptable limits of cracking would vary with the type of structure and environment. So if you want to know more about details, you can refer Annex F. Okay, you can refer Annex F of the IS code 456/2000, and you can check there are how cracking is occur, and how we can reduce the cracking width, and like that you can check the codes and refer it. Okay, you can see all in detail. Okay, next is I want to talk about the engineering design and thumb rule. So, so I basic as I think most of you heard of this. Okay, so basically engineering design, as I mentioned, we follow the basic guidelines, which standards which have given as per Indian code or which country given. Okay, so thumb rule basically based on assumption. Okay, it's purely assumption, and we just assume it and give. Okay, there is no realistic evidence like that. Okay, so next point is that Engineering standards. Engineering standards follows the surrounding condition. Okay. So as I mentioned, for IS code, each country they prepare the IS code based on their surroundings and all. Okay. Based on their surroundings, they make the IS code. IS European, every American code, every each and every country they make this code. Okay. Based on that, based on their conditions and all. Okay. Based on their country conditions and based on their area of working. Okay, but the thumb rule they can create only small structure, and we cannot be sure 100% accurate that these structures will be last as per our engineer standard. Okay, if we are building a construction for what, and as per our engineering principle, we are considering that okay, our structure will last for 100 years, 100 years. But in thumb rule, they are basically based on assumptions and all. So they cannot predict it accurately, or if they say only 2 years and all 2 years, 10 years like that. So they basically they they don't have a guarantee, or what, they don't can't say it because it's purely based on assumptions, right? We will say lots assumptions and all. Okay, so it's not wise to use thumb rules during design and all. Okay, so so always try to do it in the engineering way. Okay, so so that we follow the country rules, and topography surface like that, we design based on that. Okay, next is the design flow. Okay, design flow and all. Okay, so up till now I said about the design calculate design, how what are the principles of design and all. Okay, so we have mentioned about the working stress method, limit state method, load method, and how thumb rule and all that was our talk about. Now, how do we design a structure? If you are given a structure like column beams, like that, if we are given, so how do we design it? That's a question mark, right? So that question mark needs to be changed from this moment on. Okay, if if anyone gives you a structure, the first basic things is the load calculation. So what are loads are acting on it? Okay, if that load, live load like that, if it's it's in the open area, what's all the open loads and surrounding loads acting like that. Okay, first is the load calculations. Okay, next is the dimensioning. Okay, the next point is the dimensioning part. Okay, so for dimensioning, so if you are given a column, a client says to design a column, so they want the circular column. Okay, for for the nice appearance of their building and all. Okay, so some say rectangle column. So dimensions is the basic buttons and all. Okay, for appearance and for our easiness. Okay, so we can't. So we dimension is the second important factor of it. So based on after we fix the dimension, we can make the formwork based on the dimension and all. Okay. Next is the moment calculation. Okay, moment calculation is another important factor. That's the moment calculation on beams, slabs, everything. There's a third most important factor we need. Okay, okay, for design flow, these three are the main factors. Okay, what are all they? Load calculations, dimensions, moment calculations. Okay, these three are the main factors which we, and then fourth one is the checks and all. Okay, the checks is basically based on the structure that we design. That we design. Okay, shear check, that's mainly for column, that mainly for beams and all. Buckling check, that's mainly for column. One way and two way, mainly for foundation design like that. Foundation design, foundation design like that. Okay, foundation design we do one way and two way shear, development length, check beams and all. Okay, so next, how if anyone asks how a design works, How do you calculate a design? Someone says, explain how do you design a structure. So then you can say simply that. So first we have to calculate the load. We have to give the dimension and main moment calculation, and for each and every structure, what structure is given. Based on that, we give the checks and all. Okay, shear check, but in one way, two way, developer like there are so many checks. So I mentioned only listed only this much. Okay. So after design, our design is not over. Okay. After design, we are going to the analysis part. Okay. We have only designed the element. Okay. Structural element only we have designed only. So we can't what we can 100% sure that our okay, I have designed it. Okay, it will be very good, and it will be there stably forever. Okay. So we can't 100% guarantee that, right? So, so for that we have to do the structure analysis. Or so we are placing the beams and column for a structure, right? If it may be a two-story building or three-story or five-story G+10, like that, so many any type of building. So we have to do the structure analysis. So we design the columns and we put it in the structure where this column is needed, column, beam, slab, everything is needed. Okay. So we have to place it inside that structure. Okay, what structure we are building, we have to place it inside it. Okay, so for that we have to do the structure analysis. Okay, so if anyone have to ask you after design, is the design over, you have to say no. The final step is there. What's the final step? The structure analysis is the final step which is to be provided. Okay, so when they define the structure analysis, when you see the definition, structure analysis is a systematic development method that allows analysis to understand the functionality of the structure. Okay. Okay, we can understand the functionality, what type of structure we are building. Based on that, the beams and columns, how the beams and columns should be works. Okay. Like that we have to check it. Okay, it can be represented graphically. Okay, the results we can get it graphically and all. Okay, we can get the result graphically, no, okay, like that we can get it any way we want. Okay, based on if you do the structure analysis, it helps in checking the design of our structure and stability. Okay, whether our design is correct, or if we have any warning, what we have to change. If it is unstable, what we have to change. We can get an idea of what went wrong during the design of that part only. Okay, we will get most idea about it. Okay, can get an idea about where the design went wrong, what went wrong. Okay, what are features went wrong, like that. We can understand it. Okay. Okay, and next it helps to find out which element failed or which is able to withstand the loading condition which has been given inside the whole structure. Okay, this is well inside the whole structure. Okay. Okay, if anything is failed, or our beam is not capable of handling this much load or pressure inside it. Okay, this much load pressure inside this element, inside this whole structure. So we have to we have to redesign it. Okay, okay, like that. If the okay, we have to that. If the structure analysis is not satisfied, we have to decide the structural elements. Okay, so if you have done the structure analysis and all, okay, you've done the structure analysis. Okay, so you can see that it's not satisfying, it's not meeting our requirements. So many structures are failing. There is no other option but to redesign. Okay, there is no other option, so we have to start from the scratch. Okay, like begin from the loads. What loads are there, what went wrong, the load calculations, or the moments which are acting on it are went wrong. What each and every point we have to check through. Okay, what went wrong. So it's we are we are uh, we are we are responsible for the life of thousands, hundreds of people. Okay, we are building a structure which so many people lives inside. Maybe a hospital, anything, maybe hospital, house, anything, education institution, like that. So that's if it is not met mark up to that expectation, no, nothing, no, don't doing any scribbling inside it. Okay, just redesign it once more. We do the redesign it until it is satisfied. Until the structural analysis is satisfied, we should redesign it. Okay, That is a major policy. Okay. So if any design, so if you also have a working professional, if anyone comes across like that, you don't think that another work, redesign it, and what went wrong, recheck it. Okay, that is our main aim. Okay, that's our main aim. Okay, if you understand the importance of structural analysis. So anyone asks you after design, okay, our work is complete? No, we have to do the structural analysis. After that, only we can say that our structural design is okay. Okay. So manual calculations, so structural analysis, can do manual calculation. We have Kenny's method, and most of you might heard of these methods and all. We learn in our graduate during our undergraduate programs in civil engineering. Kenny's method, stiffness method, portal frame method, cantilever method, like that. There are so many other methods. So based on this, we can do the analysis and all. Okay, we can do the manual analysis and all. Okay. So now it's manual analysis like that we have to do. Okay. So based on this manual analysis, we will get a required result, and we can see we can find out that we can find out that we can find out whether our analysis or design is up to mark, or we have to redesign it as I mentioned earlier. Okay, we have to redesign it as per our requirements. So now currently we are not using this method. Okay, manual calculation is over since we are entering into this era of computerized and all. We are into the software field, right? So like that, use structural analysis software for analysis and all. After we design the beams and columns, and whenever we provide a plan, we provide elevation, everything. After that, we give a structure model and put it inside a software, and we check it, right? Using, there are so many software, StatPro, ETABS, Tekla Structure, Safe, StatPro Foundation, like that. There are so many softwares that we give that. So we give it inside one of the softwares, and we find out whether our structure is stable or not. If we give the warning and we redesign it once more. Okay. Okay. So I hope you know more about the software and all. StatPro and ETABS are for the superstructure design, and SAFE is for the substructure design. And the structure design is more like StatPro and ETABS, but it can do both foundation and superstructure design. Okay. So we are coming to the end of this today's session. Okay, so for now we have learned what the importance of design. Okay, as we are going through each portion, we will learn about the importance of design and how design is an important factor as an engineer. Okay, as an engineer, the importance of the design and the importance of the not only Indian standard, the whole standard. Why do we need these standards and all? Okay, what is the importance of it? Why do we need it? Why can't just we build a building according to that? Just blindly build a building. Okay, so so I have mentioned about the importance of the standard codes and all. Okay, and the next is the different philosophies. We have learned the limit state, the working stress, the ultimate load, like that. We have learned so much type of philosophies and all. Okay, so many three types of philosophy we learn, and how are they different from each other, like that we have learned, and how the design flow works. Okay, how design when you are when you are given when you are when you are asked to do a design, how to design. First we have to calculate the load, the dimensioning, the moment, and based on which element we have to design, we have to check, we have to provide the shear check, one way shear, any check which you are good, we check it. The last one is the structure analysis. After design, our design is not over. We have to analyze the structural elements using using the elements which we have to give it into the structure. Okay, which structure these elements are coming, we have to give it inside it, and we analyze it. And if it is not satisfactory up to our limit, to our expectation, we have to redesign it. There is no other option. We have to redesign it. Okay. Okay, don't think another step back. We have to redesign it. Okay.